Hi, in this lecture I'm going to tell you about the minimum you should know about testing. So the goal of this lecture is that you learn, you understand what is the benefit of having tests. So how can you trust that you made a change in some big system? So you have your big system here, and you make a change here. How can you know that you didn't break anything? Yeah. So imagine that you work in a financial system and you want that your clients don't lose any money. So in those critical places, you should know that you didn't break anything. So how can you trust that your change didn't break anything? How can you trust also that the system is working properly, even if you didn't make any change? We are going to see how unit testing can help us to do that, and how do you write tests. So what are the main points of testing? So if you make a change in your system, I have my system here, I make a change. So what is a test? So a test will verify, it's a piece of code that will verify automatically that everything that was depending on this piece of code that changed it is still working, yeah? And it will tell you, yeah, it's okay, it's okay, it's okay. So in this sense, tests are like a life insurance. You can get aware of a regression or a side effect in the system that you were not expecting. So you can go over and change stuff here and there, and you know that if your tests are okay, then you should be at least confident that you didn't break anything. So it actually removes pressure from development. In that sense, also tests will enable future evolution, because that means that we can freely go and change things in the system and knowing that we didn't break anything. And it removes fear from change. So you're not going to fear that, what are the possible things that may be broken if I change something? So you can just change something and see if your tests are broken or not. So, of course, tests will not prevent bugs, but they can help you detect unnoticed problems in the system. I'm going to insist very hard in here that an automated test actually does not exist. So what is important about the test is that it can be executed many, many times automatically and without any human intervention. The main goal of a test, of an automated test, is that you can make it run, for example, in a robot, in a continuous integration environment. We can make them run in a loop every time that there is a new change that comes into the system. So we can integrate something, a new change. And if something breaks, we are going to automatically be notified of something that happened. Unit tests will get sure that also you can correctly specify the behavior of a class. You can not only try to check that everything is working okay, you can use them to document the behavior of your system. What we're going to say is that a unit test will test a single feature. That is why it is called a unit test. So it doesn't test a big part of the system. So we're going to split our system in many small pieces. Usually, each one of these pieces is either a module or a feature. Feature 1, feature 2. And then each test is going to test one of these features. You have to think that tests are like a scaffolding. So they are actually surrounding your feature to make sure that it will work. If you make one test per scenario, this also will make sure that you will identify really clearly when there is one feature that is broken, and you will not get polluted results. So if this feature is broken, you want to know that this feature is broken and not all the dependent ones. So being able to identify each feature in isolation helps you to detect the causes of the problems before. So what is a test? So a test has three main parts. The first, it will have a context, which is the main description of the scenario. Then we have stimulus. So something that we do on top of that context to provoke a change. And finally, we have a check of how that stimulus should have, what that stimulus should have provoked. That we're going to check with assertions. Yeah. So we have something, so we have a scenario, we're going to make a change, and then we're going to observe what happened and test that our observations of the system satisfy what we expected. Let's go with a concrete example. Here, for example, we can apply this template of a test to testing sets. Yeah, a set is a collection of objects that doesn't support duplicate elements. Yeah. So in this case, our set, if we try to add a duplicate element, it will only add the first 1, and the second time we add the same element, it will just ignore it. Yeah. So in this case, what is our context? So we create an empty set. We create a set that doesn't have any element. Our stimulus is that we're going to add twice the same element to that object, to that set. So the first time that we add the element to the set is going to store it. The second time, the set is going to ignore it. Or that is what we expect. In the third part of our test, we are going to check exactly those expectations. So we are going to check that the set contains exactly one element and not two. So it should have ignored the second element. Translating that to code in Pharo gives us something like this. So here we have one class, which is a subclass of test case, and is where we are going to store all the tests for sets. Yeah. And then each of the tests is going to be written as a method. So here, for example, we have the test add is our method that is going to express our testing scenario. So here our test, we have divided it in three parts with using comments. So here, for example, we have the context, then the stimulus, and then the check. So the context is doing exactly what we said before. We are going to instantiate the set and store it in a variable. Then we're going to add 2 times the same object. And then we're going to assert that the size of our set is equals to 1. The same test can be written in Java using, for example, JUnit 4.0 in this way. So in Java, we can inherit from object directly. And then to mark a test as a test, we need to use the test annotation. And then the test goes exactly as it was before in Pharo. So we need a context, a stimulus, and a check with an assertion. When we run tests, 3 main things can happen. We can have a success, which means that the test ran okay and all our expectations work correctly. Second, we can have a failure if one of our assertions did not work as expected. So, for example, our assert collection size equals 1. This didn't return 1, it returned 2. So we will have a failure if an assertion doesn't work as expected. Third, we are going to have an error if there is an unexpected condition, such as, for example, an exception at runtime. For example, here, if our set implementation is not correct and we have 2 elements, 2 times the element 5 inside the collection, and this returns 2, here we're going to have a failure. Usually these, in testing frameworks, they are set with the yellow color. We can have an error when, for example, we have an unexpected exception inside the test. So, for example, here, we have a test that is asserting something. In this case, we are asserting the same thing as before, but we are sending this message that is an unknown message. The full bar method is not in the set hierarchy. Yeah. So here, this will rise a does not understand exception. And since our test was not written to expect an exception, this is an unexpected failure and also called an error. Now, what happens if we have many tests that have the same context? There is one way that is provided by many testing frameworks to reuse the test context. So, why do we want to do that? Because duplicating the test context will probably cause problems in the future if we want to evolve our tests. So if we want to change the context for all our tests, then we have to change all the potential repeated code. So duplication is never a good idea. So this means also that changing the test will be more complicated. So people will think 2 times before changing something, and that is not good. So we want to be able to change the code much easily. Not only the code of the application, but also the code of the test. So most of the frameworks offer then this setup method that you can redefine to create a context that will be executed before each test. So in this case, what will happen is that imagine that we have 4 different test methods, so the test 1, the test 2, the test 3, and the test 4. So if we have a setup method and a teardown method, the setup method and the teardown method will be executed before and after each test method. So in this case, we are going to execute the setup, the test, then the teardown, then the setup again, the test, the teardown, the setup, the test, the teardown, and so on. So this setup will allow us to reuse the context. So we are going to be able to initialize our context only once in the code. And this will be executed many times by the framework automatically. And the teardown will help us to clean up the system. So this is also useful, for example, if the setup is creating a file. Usually the teardown can tear down or destroy the file to avoid that our test leave a dirty system behind. To do this, for example, one thing that we can do to refactor our previous test is that we can define empty. Instead of using a temporary variable, we can use an instance variable, an attribute of the class, and the setup method can set that variable that we can then use in the test. Remember, tests help us to trust the system. So you don't need to build all of them at once. You can build them incrementally and on demand. So every time, for example, one strategy to manage the writing of tests is that every time that we have find a bug, we can write a test for the bug. And later, if that bug reappears, if we have a regression, our test will actually detect that problem. One way also to develop the system that will be handled in a separate lecture is that we can write the test before the code as a specification. Yeah, so you want that your system behaves like this, and then you can implement the behavior for that test. So this is going to be talked about in the lecture of TDD. Also, since tests then can be thought about as an active documentation that is going to be executable, it's always in sync with your code, because if you run your test and you make sure that your tests are green, then those tests are actually specifying what should happen with your system. However, be careful, because writing tests, they have a cost. So you have to write them, you have to maintain them, you have to run them, maybe in a continuous integration setup, so they consume also energy and runtime. So be sure that you make them worth. But the payoff is huge if you can ensure that. Of course, you cannot cover everything with just tests, so nobody can, really complicated. So some strategies that you can use to define tests is that write tests when you find a bug, instead of trying to write tests for all your code at once. You can then, once you have the test that is breaking, either with a failure or with an error showing the defect, then you can fix your code until the test succeeds. Taking this to the extreme, you can use TDD, that will be treated more in detail in another lecture. But the idea is that you are going to start with the test. You are going to use the test not for testing, but actually to describe the behavior of your system. So the test is actually, you start from writing the specification in an executable way, and then you are going to implement the specification written in your test. So tests are going to be written step by step as you develop and as you increment the features in your system for every new piece of functionality. What makes a good test? So if you want to have some thumb rules, so the first thing that is important is that tests should be repeatable. So you should be able to run them many, many times without any human intervention. So why? Because you want that to run in a CI setting, for example, in an automatic way. You would want that your tests don't write files that are not deleted later, because maybe if you write a file and you don't delete it, maybe a later test will fail because of a previous test wrote a file. So you want that somehow the setup and the teardown ensure that that test doesn't leave anything dirty in the system. You don't want any human intervention. You want that the test automatically tells you if everything was wrong or not, and if something went wrong, you want that the test automatically tell you what was wrong in the system. You want that the tests are self-described and easy to read, because tests are not only for the machines, but also for the people that are going to use them as documentation. And you have to make sure that tests change less often than the system, otherwise they don't pay off. So that is why the test should be more about the specification than the implementation. Like that, you can change the implementation as much as you want without changing the actual specification. In a conclusion, so invest in writing tests. They are the best scaffolding and the best let you trust the system that you're writing. You can use TDD and Xtreme TDD, starting by writing a test, and then making that test pass and making it green, and be sure that tests are a good investment.